All right, so this is the Math Intense review class. This class will aim to review pretty much everything that we did in all the various math classes, and then maybe point out a couple of things that are more advanced, but I am also working on, and by the time you're hearing this, I probably already have a lot of supplemental videos that go into more advanced skills because my program has to factor in the differences in scores that people are looking for. So if you're looking for a 70 or a 75, I would not want you to be stressing yourself over some of the really, really advanced questions that are few and far between when you get to the test, because you don't need that 1 or 2 points that somebody might need if they're trying to get like a 95%. So I'm kind of going to play to the middle a little bit with this, similarly to what I do with the regular primary math classes. If you are trying to score in a really, really advanced area, you may want to look at certain smaller supplemental videos for certain skills. I'll try to point them out when we run into them. So if there is a much harder version of something, I will do my best to mention that it is one of those things and that there might be a supplement if you want to get more into it. There are a couple things I'll point out here that I did not point out in the other classes that is a bit more advanced, because if you are taking this class, one of two things is happening. Either you have scored really, really well on math and we're going for a little bit more of a review and overview type thing to just help you streamline your strategies, or you have taken all or most of my math classes already, so you're kind of familiar with what my strategies are, and this just aims to kind of put them all together. So if you're in one of those two boats, you have slightly different goals and targets. This class will try to play right to the middle of the different possibilities, and then you can let me know if you are in one of those groups and you do want more information or different information, or you do want to go into the harder stuff. That will be an option. It will just be in a different format. This will be a long class. I'm not exactly sure how long. Intense review classes are usually a couple of hours. By the time you're actually hearing this and watching it, you can look at the timestamp on the video right now and see how long it did turn out to be. Intense review, it is recommended you do the whole thing at once. So if you don't have the 2 to 2.5 hours that I'm guessing this class will take, you'll probably want to do this class at another point unless you're super crunched for time to your test and you have to just get in what you can get in. So this is kind of in the order that you did your classes, I guess. The first few things are from fundamentals. This is definitely from fundamentals. One of the things we talked about in fundamentals is making sure you know how to do a mean and a median. Mode is actually not something that's on any of the entrance exams, so you can cross out mode. This is just a generic worksheet. So you want to make sure you know how to get a median and how to get a mean. So to get a mean, we'll do the first example. You want to add all your numbers up. Remember that a mean is the same thing as an average. So we want to add up all of the numbers. And then we want to divide by the quantity of numbers that there are. So in this instance, we have 8 different numbers, 1, 2, 3, 4, 5, 6, 7, 8. So we're going to add them all up first, and then we're going to end up dividing by the 8 numbers that are there. In order to do this, you definitely want to use your calculator. I will make a couple of notes about the calculator. It's very, very crucial that you have some experience with the calculator before you go. The calculator is built into the test. They just updated how the calculator looks and how it's built into the test, and they just made a couple of changes that kind of let you still mess with the screen while you have the calculator up, and that's a really good thing that they kind of added that ability in. I'm mostly going to be using a graphing calculator for the sake of speed and accuracy in this class, but you, as you are practicing your math, should be using a calculator that is designed for using on the computer with a mouse, essentially. I'm sure that you have one built into your computer. That is the best way to ensure you're not thrown off by taking a mouse and clicking the buttons on a calculator. It's much easier to make a mistake with this type of calculator. It's much slower to progress with this type of calculator. And it actually is kind of noisy when you're clicking the buttons with the mouse and you have people that are right next to you. So if you're one of those really considerate people who worries about whether you might be bothering someone else, you want to get used to the fact that it does make that sound when everybody gets to the math test. It's like you're in a weird twilight zone full of mouse clicking because everybody's using their calculator, but you want to be prepared for what it's going to look like and feel like, and what you're going to need to watch for and what your setbacks might be. So practicing with whatever your computer has built in can be helpful. Like I said, I do that in a lot of the math classes that you've already seen or might have already seen. I'm not going to do it much here. So I added up on my own what the sum of those numbers was, and it was 167. So you're ultimately going to have these total up to 167. You're going to have 8 of them. So you're going to take 167 divided by 8. This answer turns out 20.875. They didn't say anything about rounding on this particular worksheet, so I would just leave it the way it is since it's got 3 decimal points. But keep in mind that's not an issue when you're actually on the test, because if there is rounding involved, they're either going to tell you how they want it rounded, or you're going to look at your answer choices and they're all going to have the same rounding. So all of your answers might have 2 digits like this, and that might tell you that you're going to use 2, or all your answers might have 3 digits, and you can kind of adjust your thought processes to that. So always kind of glance at the answer choices. They'll always look the same. They're not going to have one answer rounded one way, the next answer rounded another way. So that's a good way to find out how they want you to do that. It is possible that they might have wanted you to put this one up to a whole number and say that the mean is 21, but that will either be in the instructions or it will be indicated by the answer choice. So the median is the middle number. That's the one we don't emphasize as heavily because it is a more rare question type. The key to the median is something I see people leave out all the time. You have to put the numbers in order before you do a median. So we can't use the list that they gave us because that list is not in order. So if you're trying to find the middle number, that will be skewed if your numbers are not in numerical order in the first place. So this is what the list looks like when I do get it into numerical order. One of 2 things will happen with a median. Either there will be a middle number, or there will be 2 middle numbers and there's not a perfect middle. That's what you're going to see in this case. So as you count from the left and the right, you can cross out 1 and 1 and then 1 and 1 again, however you see fit to make sure that you're moving exactly the same way on the left and the right. You're going to get down to 2. This is an even number. 8 numbers is an even number of pieces in the set. So when you get to the middle, you've got essentially 2 medians, and you're supposed to average the median. So you still end up using your averaging skill on this one. You're going to add up 18 and 21, and you're going to divide by 2 because in this instance, we're just dealing with 18 and 21. There's 2 of those numbers, and you will get that right perfectly between the number 18 and the number 21 is the number 19.5. Mode is the most commonly occurring number in the set. I've never seen a mode question on the entrance exam, so I would recommend taking it off. I will put it onto the answer key in case you want it for something else, but I won't talk about it as far as class goes. So you have several examples here that you can use for mean and median. There is one thing I want to touch on very briefly. When they put a negative number, so I'm on the second page now where I have some lists that include negative numbers, that can actually throw a major curveball from the standpoint of using their calculator. So in this set, I have 5 numbers and one of them is negative. What I recommend doing, and you have to move the numbers to your scratch paper anyway, because when you did this, you were able to just do it on the paper right there. When you do your test, you have to do everything on scratch paper. So you have to move your numbers as it is. And while you're doing that, while you're copying your numbers down, what I recommend is just copy each of the positive numbers first. So I got 8, I got 4, I got 9, and I got 3. Leave the negative as the last one. And instead of dealing with a negative function on a calculator, which is very unreliable, you'll end up just subtracting it at the end of your list. So it's very, very dangerous with the calculator to do something where you're like 20 and I need that negative, because you have to hit the buttons in a very certain order for the calculator to understand what you're trying to do. So it is a very bad plan to say 8 plus 3 plus -4, because you have to do a really weird sequence to get that -4 plus whatever. Obviously, it's doable. If you're looking at my list right here, you can see I got a -4 added in there. The odds of hitting the buttons correctly to do that are not very good. So instead, have it where you add 8 plus 3 plus 9 plus 4. And from that total, you can -4. And that is the exact same thing as adding a -4. What I'm going to end up getting is 8 plus 3 plus 9 plus 4 minus 4 is 20. And then there are 5 numbers. So I'm going to divide 20 by 5, and that's going to give me 4. There are more of them that have some negatives in there for you to practice. There's all different kinds of scenarios and everything for you to practice. You want to make sure you can very quickly and accurately get an average or get a median. Medians are tricky because you can't count on their list. Even if it might look like they have it in numerical order, it might not be. So you have to count on saying, I'm going to take those numbers myself. I'm going to put them in order. And then you have to remember that if there are 2 numbers in the middle for a median, that you have to average the 2 of them. So the next page is ordering rational numbers. This is something that's sort of evolved in the last 6 months on the T's, and it's something that they always kind of mess with a little bit. There's not quite as much right at this moment of having to put them completely in order where you have like 10 different items and you're putting them in order. There's been a little bit more of like a list of fractions and them saying which is the least or which is the greatest. So that's what my first couple of examples are. I do have order an entire set from least to greatest on here because that is still one of the skills that you need. But you want to make sure you're prepared for these because they might be a bit of a curveball if you are just used to putting things in order. They usually use fractions because they figure that a lot of people will, I don't know if lazy would be the right word, but will be lazy or just will not compare them really carefully. You should never use fractions as fractions. You can't glance, even someone like me that thinks about math all the time and is really good at understanding how numbers relate. I can't necessarily glance at this and tell you like how 3/7 compares to 4/9. That's not something that I could do. If they all had the same denominator, yeah, then you would have like 1/7, 2/7, 3/7. Obviously, this would be the biggest. That would be the smallest because we can see them all in the same light. When they're not over the same denominator, which they never will be, we need to make them into decimals. So one of the skills we learned in fundamentals is how you turn a fraction into a decimal. You take the top number and you divide it by the bottom number. So to get the 0.4 I just wrote down, I took 2 divided by 5 in my calculator and it gave me 0.4. There is something I'll address after I write out this list. So I'm going to keep doing that. I'm going to put each one of them in my calculator and divide the top number by the bottom. Make sure it's the top number getting divided by the bottom number. We want them to come out decimals. So don't flip them. Do top divided by bottom. top divided by bottom. You will find that in some instances, your calculator will give you more decimals, in some instances less. So 0.4 comes out that way. That's how that comes out in a calculator because it's perfectly even. 0.33, I rounded down because it's 0.33 and repeats with threes forever. So I rounded that to 2 spaces. And then I think it was the same situation with a couple of these other ones. A question that you might ask is, well, how many decimal places is appropriate? How many should I have? Should I keep more numbers or should I round them down? I always say 2 is the most classic. There are going to be instances where it only gives you 1, and that's fine. There's going to be instances where it gives you repeating decimals, and there actually will be an instance here and there where you have to have more than 2. So, for example, if I've rounded all of this, and let's say that before I rounded, I had a 0.3333 and I had a 0.3335, for example. That's not what I had. In this case, our numbers are nice and far apart. It's really impossible to get them mixed up. In a situation like this, that third number is going to be impacted by rounding. So these are not identical. If you rounded these down to there and you didn't even think about it, you'd have 0.33 twice and they would be exactly the same thing. So you have to look at your numbers, whatever you have in your scenario, you have to make an appropriate decision for, do I need to go further? Do I need another decimal or not? Because this is going to cause us to have 0.333 and 0.334. Those are not equal. So if you put those in order and you don't account for this right here changing, you would get that wrong. You can't say 0.334 is the same size as 0.333. So that's just a random example of where it might matter. A random example of where they might not give you as much is like the 0.4 over here. That's all my calculator gave me. The reason I say 2 numbers is classic. I'm going to write that on there again. We understand numbers that are 1 digit and 2 digits really well. Our brains naturally work that way. You look at this and you see 33, 43, 25, 44. It's very easy for your brain to decide how those relate to each other. When it gets up into 3 digits, it's still not difficult to see how the numbers are making sense, but it's not as convenient. So if I was to have each one of these was a little bit longer of a decimal like this, it would be a little harder for me to make the comparison because now I'm having to look at them as hundreds and there's more to compare with. There are instances where you can't be accurate enough unless you have more decimal places. There are instances where it's so accurate that they'll only give you 1 like this, and you can just put a 0 there. So if you like comparing these as though there's no decimal point and they're just numbers and it's 40, 33, 43, 25, and 44, that's how I think of them. I added a 0 to this so that it's along the same lines. If you get 1 decimal point, if they give you 1 simple decimal point, there is always an infinite number of zeros that come after that. So depending on how your other numbers look, depending on what your comparisons are going to be like, this is what you would do, is just add a 0. That way they're all level. It doesn't really matter, it all kind of depends on style as far as exactly how you do decide to round and how you do decide to compare. What I will tell you is it becomes close to impossible if they're not the same size. So what you don't want to do is have a 0.4 and a 0.33 and a 0.428 because you definitely can't accurately compare those when they're not in the same playing field. So you would want to add a 0 to that. You'd probably want to take those off and round that so that they're all the same size. The numbers being the same size takes it from, this is decimals that we're comparing. Nobody likes decimals. Nobody thinks naturally about decimals, to this isn't really decimals. It's like 40, 33, 43, very easy to put those in order. This wants to know what is the least. When you're looking at them as decimals, you can see that 2/8, which is 0.25, is the least in that particular scenario. The smaller the decimal number, the smaller it is. So you'll have more of them that are like that. I'm going to skip down to the third one, which is the first one that says order. You have to be very careful whether they're saying order from least to greatest or greatest to least. Our brain naturally puts things least to greatest. So if it says greatest to least, there is a much higher chance that you'll actually do all the right things, but you'll put them in the wrong order and you'll end up with least to greatest. So if it does say greatest first, you have to really pay close attention to the fact that it says that. This one's going to move in our natural order. Again, same thing we just did with that, except we have numbers in all different realms here. If it's a fraction, you cannot use it as a fraction and compare it, so turn it into a decimal. Again, I'm going to target having 2 decimal places unless I realize that I've got stuff that's too close together and that's going to screw me up, in which case then I can go back and I can make my numbers bigger. So always target 2 in the first place. You're never going to be able to completely tell what's going on until you just get them all changed. Some of them already are decimals. So that one was already a decimal. That one and that one, we're not actually doing anything with those. We're just kind of copying them down. Although you might notice this is the one number that's not 2 digits, and that makes it seem confusing when you're trying to compare it to 2 digits. Now that I have my set sitting here, I can look at my numbers and determine, are they so close together that I need more decimal points, or do I have enough space? So a couple of them that would be concerning is that and then that. So what you want to make sure of is when you created this decimal number here and when you created this decimal here, did you round them accurately? Because if you did, then they're not the same number as the one next to them. 1/7, if I take 1 divided by 7, is 0.142. So that really does round down to 0.14. That really is not the same as 0.15. I've got enough space. With 2/9, it is literally 0.222 repeating like this. So again, I can't mix up 0.22222 with 0.23. They are very close, but they are not the same number. You could go back and discover that you actually rounded something wrong and that they actually were the same. And if they are the same, then you have to be extra careful to keep any extra places that might differentiate them. This one right over here does not need a 3rd decimal. So I'm going to round this to 0.28 because I don't have anything that is so close to that number that I need that for differentiation. So now I'm in 2 digits. I'm going from least to greatest. Again, I just have essentially a collection of decimal numbers. My one that's the least is 0.14, followed by 0.15, followed by 0.22. You'll notice I am putting them in order in the format that I have them in this step. So I'm not using the numbers the way they were up here. I'm using my decimals that I just created. You can't answer it that way, but that's the best way to make sure you're truly in order. So you finish this up, you read it again, you make sure they really are in least to greatest order and that you're confident in that. Now you actually do need to go back and change back to the original format of the number. So we wouldn't answer with 0.14 in the least spot. We would answer with 1/7. 0.15 is the original form, so that's going to stay the same. 0.22 used to be a 2/9, so we need to change that to that. 0.23 used to be 23%. 0.25 was already 0.25. And then 0.28 we need to take back and make it 0.278 because that's how they had it. So this here would be your answer. A quick tip on these. A lot of times on the test, and don't count on this. This is just something where you're going along on the test. You're feeling good. You're confident. You're doing well on time, but you'd love to save some time. when you look at the answer choices on these, sometimes this is almost a dead giveaway. So you still have to have changed everything into a decimal. You still ultimately need to kind of put everything in order, but you might be doing too much work if you're like, let me convert all of this back. In some instances, the answer will be that close to where there's like two of them that are almost perfectly in order. One of them is just off by a teeny tiny digit. Usually, there's only going to be one answer that has the smallest value correct and the largest value correct. One or two answers. So if you see your answer choices and some of them are starting with 0.22 or 2/9, some of them are starting with 0.278, you know those aren't going to be right because they don't even have the first value in the right place. So check for that and eliminate anything that you can eliminate based on the fact that the first thing is wrong or the last thing is wrong. So when you look for your answer, look there, then there. Guaranteed that will get you down to two answers at the very most. There's only going to be two answers that actually have the front and back correct. Then you can go one more value this way. If you still have two answers that have the correct value there, you go one more this way and so on. But what you'll find is there's really only going to be one answer that's even close to the right answer. So you might be wasting time to really scrutinize all the rounding and to put everything back in its format because they may not even have answers that are close. So check for that. Whenever I get one like this on the test, I always kind of look at the answers, and sometimes you can immediately see that a value is definitely not the least, and a couple of answers have it on the far left like it's the least, and it'll be obvious to you without even doing any work that that answer shouldn't work. The last one I'm going to do for this is the one that has some negatives. There's a couple of different ones with negatives. I'm going to do the second from the bottom one, which is this one. Be careful with this because it does say greatest to least. I'm not kidding when I say that's easier to screw up on than if it said least to greatest. And so when you have negative numbers, there's varying degrees of difficulty with that. In this case, the negative numbers are placed together, and in some cases, they're not. So in some cases, you'll have like positive, negative, negative, positive, positive, negative, and you actually have to go hunt down the negative values to find a list of negatives. In this case, I'm not having to do that. I have negatives here. I have positives here. Why am I talking about negative and positive at the beginning? That is the most crucial piece of greatest and least. So if we're going from greatest to least, we know for a fact that those three negative numbers would have to be the last three things in our list because they would have to be the least. So we know that whatever's the greatest, whatever's going to start up our list on the left is going to be from this list here. And we know that we're going to see all of our positives, all 5 positive values first. Then we'll start to see negative. So even though they do have them listed together, they've got them flip-flopped. These are going to wind up over there, and these are going to wind up over there. Then you want to do your negatives separately from your positives. So don't try to think of it all at once. Let's do the positives since they're supposed to be on the left. So our positives are these ones here. Again, do what you normally do with putting them into decimals. So that one's already a decimal. It's 0.5. This one is 0.05. 1/5 will be 0.2 when you divide. 5% is 0.05 when you put it into a decimal. 50% is 0.5 when you put it into a decimal. So those are my positive values. Again, we're going from greatest to least. So I have 0.5, 0.05, 0.2, 0.05 again, and 0.5 again. So you may notice there's 2 that match. Those 2 are the exact same value, and they truly are. There's no rounding mistake there. And then this one is the exact same value as that one. If ever you notice that, it does not matter which one is which. There will only be one answer that has them correct. They won't make you split hairs between the 0.05 and the 5%. They are exactly the same. So from greatest to least, My greatest values in this list are my 0.5s, and I'm going to put my work down here so that you can see it. So my 2.5s, and remember, you can add a 0 to those if that helps you discern between your different ones. So 0.5 or 0.50, that is my biggest value. And I have 2 of them, doesn't matter which one is which. So I'm going to put those 2, that gets rid of those. My next biggest value is going to be the 0.2. So, and that's 0.20. So you've got 50, 50, 20. Then you have your 0.05s, and we have verified and re-verified that we didn't make a rounding mistake. Those are supposed to be identical. One of them is 0.05, the other's 5%. Those are truly identical values. So our 0.5 and 50%, those are exactly the same. So here is my greatest to least order for my positives. Separately, I'm going to look at my negatives. I know they're going to wind up right here because they're least. They're going to be less. And so what I'm going to look at is I've got -4. That's a whole number 4. So that is going to be the very smallest value by a lot. Remember, negatives work oppositely from positives. The bigger a number is that's parked in front of a negative sign, the smaller that actually is. So this is like being overdrafted $4 in your bank account versus this -0.5 is more like being overdrafted 50 cents. So this is the very smallest. We immediately swap our thought process when we swap signs. So when you're working with negative, you're going greatest to least when actually you're going least to greatest. So you can either think of it with the negatives in context, or you can kind of ignore them, but tell yourself you're doing the opposite process. So I could ignore the fact that there's negatives here, and I could tell myself to go from least to greatest, because that's the opposite of what I'm actually trying to do. If there weren't negative signs, I would be going least to greatest. Because there's negative signs, it becomes the opposite. And then my last value is 0.45. So this one, it's crucial to put a 0 on the 0.5 when you're making your comparisons. So 0.50. And then -0.45, because 0.45 is 45 cents. 0.50 is 50 cents. So you think of it as how much money do I have if I have these values. So if I start at the beginning of the list, this would be 50 cents in my bank account. This would be 20 cents in my bank account. This is 5 cents in my bank account. This is me overdrafted 45 cents. This is me overdrafted 50 cents. And this is me overdrafted $4. So I can put my negatives into their spot, and now we can blend our positive list with our negative list. And this is going to be the final answer. So the bottom line there's other practices for you to do, but when you get a list that has negatives and positives, separate them from each other, separate your thought processes, start with your positives and put them in whatever order you were told to put them in. Then do your negatives, and just be keenly aware that when you're doing negatives, it is the opposite process of when you're doing positives. I'm going to fly through fractions really quick. You may recall that in the fractions class, we did a lot of different things. I want to remind you of where to keep your mindset on stuff like this. The key of this class is how you're thinking about this. And I should stop and mention something. Remember that with math, with every question in every category, but especially with math, it's all about making sure that you recognize a question right away. When you read a math question, it should come up as one of your classes that you did. So you read a question and you say, oh, that's a fraction question. More specifically, it's adding mixed numbers. Or you might say, oh, that's a geometry question. More specifically, it's an irregular rectangle. Or that's a proportion question where we turn a ratio into a proportion to find out the value of something else. So that should be the first thing you are doing. The first place that you're putting your mindset should be, what question is this? What are the types of this question that exist? What kind is in front of me? So it's important to understand what is there that could be recognized. So reducing a fraction is not really a skill that they're just going to straight ask for. It's more of something that they're going to put as part of something else, something that's bigger. So reducing fractions is an important background skill. You'll always have to recognize that that is something that any given problem in any given category could wind up with. So reducing fractions, there's really two possibilities. And this is the important thing to make sure you remember when you go to review these. So the two possibilities for reducing fractions are that the numerator could fit into the denominator. So there's two possibilities for what you might recognize to be true about something you're reducing. Either the numerator fits into the denominator or it doesn't. Those will create two very different thought processes. That is what you check for. The key to this review class is to make sure your focuses are on these big, important things that you're supposed to recognize and implement. This is it when it comes to reducing fractions. So as soon as you see that you need to reduce something, you should always look for this to be true or to be not true. So you should ask yourself, does the numerator in this instance fit into the denominator or does it not? An example where it does would be number 1 up here. So 2 fits evenly into 12. That doesn't take out the work. That doesn't mean I don't have to do work, but it does mean I don't have to think about what to make my denominator, or what to make my dividing number, I should say. So automatically, if the numerator fits the denominator, the number that is the numerator is what we're going to divide both the top and bottom by. You're always going to wind up with a 1 on the top when this applies. So not only is this principal number 1, your numerator will be number 1. And then 12 divided by 2 is 6. So if you use that first scenario where the numerator is your reducing number, you will get a 1 on the top and then whatever number on the bottom. An example where this doesn't end up panning out is like number 3 right here. So you look at this, 18 doesn't fit into 36. Actually, it does. You know what? There is not actually a scenario on here. There's one. There's very few scenarios on this worksheet. So you can do 3, but 18 actually does fit into 36. There's one scenario I can see. I'm still looking for another where it doesn't fit. You had a lot of these on your other worksheet as well if you didn't ever do your whole other worksheet. 32 definitely doesn't fit into 36. And that's number 28. That's down in the other corner. So if the numerator doesn't fit into the denominator, then we actually have to come up with a reducer. So the cool thing about when the numerator does fit into the denominator is we don't have to think about what number we should reduce by. When it doesn't fit, we ourselves have to come up with what number are we going to use. It's a very common strategy and it's a very bad strategy to just guess and to just try things. So if you remember, I taught a very specific strategy in this class for how to not be guessing and how to make sure that you're using the right thing off the bat. There's another one. 24 is another one that we'll do. So 32 and 36. What I need to do here is I need to pick one of those numbers that I want to list out factors for. I'm going to say 32. It's a little bit smaller of a number. So what are all the ways, and this will be a very quick process when you've practiced it some, what are the ways that we could build a 32 using multiplication? So there's always 1 times the number, 1 times 32. 32 is also 2 times 16. It's also, so there is no 3. And you can still list it out, 1, 2, 3, 4, 5, 6, 7, 8. You just might not have a number for every one of them. 32 is not divisible by 3, so we don't put that on the list. 4 times 8 would make 32. There is nothing times 5 that would make 32. 6 times 6 does fit, doesn't it? Nope, 6 doesn't fit either. 7 definitely doesn't fit. And then there's 8 times 4, but you'll notice you already listed that factor. So there always comes a point in your list where you're doubling back and you're just swapping your order and seeing the same things pop up. So 4 is the biggest factor that we need to list here. Now that we have this list right here, we know every possibility for what number we might end up reducing by. You've already determined that the numerator does not fit into the denominator. So you've also determined that 1 and 32, or 1 times anything, that's not going to be the answer. If 32 were to fit into 36, we never would have made a list of factors and this would be irrelevant. So this first factor is always something you can cross out. That really only leaves us with 4 possibilities. It could be 16 that we reduce by, it could be 8, it could be 4, or it could be 2. And the way that we're going to find that out is we're going to take 36, we're going to take our other number, and we're going to try dividing it by these different numbers. We start with the largest one because the whole point of doing it this way, instead of just guessing and dividing by 2 and then dividing by 2 again and then dividing by 2 again, the reason I'm against that and the reason that I do this with my factor list instead is to make sure you're getting the biggest number you can use. If you use the biggest number they have in common, you won't have multiple steps, which gives you a lot less of a chance to make a mistake, and you'll be absolutely certain that your final reduction is the best possible answer and that it can't be reduced again. So 16 doesn't work, you might have noticed. What's my next biggest number? My next biggest number is 8. 8 also doesn't work. And when I say doesn't work, what I'm saying is in your calculator, you're getting a decimal. So you take 36 divided by 16 and you get 2.25. We need an even number for it to work, so that doesn't work. Our next number in line would be 4. 36 does, in fact, divide by 4. And obviously 32 does, or it wouldn't be on our factor list. So that is going to be the biggest number we can use. We don't need to test the 2 because if 4 works, we want to use 4, not something that's smaller than 4. So 32 divided by 4 is 8. And 36 divided by 4 is 9. You might remember from class that I mentioned if the top and the bottom, if the numerator and the denominator are 1 digit apart from each other, like 8 and 9, or 7 and 8, or 1 and 2, that by default means you're definitely reduced all the way. There's only a difference of 1 here, and reducing by 1 wouldn't change the number. We will do 24 really quick. I don't want to stay on fractions for very long, but to get used to factor listing, let's do the same thing with 24. Again, you pick whichever number you want. It doesn't really matter. What I do is if there's one number that I know a lot more about than the other, I will definitely use that number and list the factors for that number. If they're kind of equal and I feel kind of the same about both of them, I always use the numerator. So 28, 1 and 28 could make 28. That's always going to be one of your factors, and it's never going to work for what we're trying to do. So we'll skip ahead to 2. 2 times 14 would make 28. 28 is not divisible by 3, so that won't be in our list. 4 times 7 would make 28. There's not going to be a 5. There's not going to be a 6. And that's going to put us back around to where 7 shows up again. So that's all that we need to list out. Usually it's somewhere between, I guess, 4 and 6 factors that you list out, pairs that you list out. Now we want to look at our very biggest one. So let's get rid of anything that's not relevant here. We have these 4 numbers that could possibly be the reducer. If you try 14 and you divide 35 by 14, it doesn't work. Our next biggest number in line is 7, and 7 does work. So we're going to use 7. 28 divided by 7 is 4. 35 divided by 7 is 5. So practice more of that. You can make up any fraction that you want also. Keep in mind, some of these have zero reduction, and zero reduction sometimes means you just cross out the zeros and you're done. Sometimes it doesn't. So for example, 21 up here at the top, I'm in the first row. 10 over 50, if you get rid of the 2 zeros, you just have 1/5 and you're done. If you get rid of the 2 zeros on the problem directly to the left of that, you get 2/4, which is not fully reduced, and you still have to do reduction strategy number 1 to get your final answer. So remember, always cross out zeros. If you have a 0 on the top and bottom at the same time, you can cross them out. You can simplify your number. It doesn't guarantee that the number is reduced. So adding and subtracting fractions has some similarity to reducing fractions in the sense that there's kind of 2 ways it could happen. So with adding and subtracting, we need the common denominator. That's why nobody likes adding or subtracting fractions, is you have to have a common denominator. There are 2 ways you could pick a common denominator. The first thing you ask yourself is, does the smaller number, so whichever number is smaller of your 2 denominators, does it actually fit into the larger one evenly? So does the smaller denominator fit evenly into the larger? So you have 2 possible scenarios. You have a scenario where the smaller of the 2 denominators does fit into the larger, and you have a scenario where it doesn't. So yes would be your first scenario, and no would be your second scenario. An example of yes, the smaller denominator fits evenly into the larger would be number 2 on this page. 7 fits evenly into 21. That takes the guesswork out of what my denominator should be. And my denominator will automatically be that bigger number that the smaller one fits into. The no, so an example of the no scenario is number 1 on the same page. 4 does not fit evenly into 7. So if it doesn't, there's only one good way to go about it, and that is to multiply them together. This is one of those things that other people may argue there's a different way that is better to do them. Here's what I think about this. If you always multiply the 2 denominators together when they don't fit one inside the other, you have a consistent, stable process that you use every time, and you do it in the same way every time, and that's a lot better than being random. And sometimes you do it this way, other times you do it that way. What I'm referencing is some people would say, well, but there could be a smaller number that they both fit into that's not as big as what you get when you multiply them together. Could be true. but you could also end up guessing what that number is wrong. I've seen it happen a million times where somebody's like, oh, wait, let me just think about 4 and 7. Oh, they both fit into this. And they end up picking a number that they don't actually both fit into. If you always multiply your denominators together when you get the answer of no, you will always have a denominator that works. In this case, 4 times 7 is 28. That is the smallest common denominator you can get for those two numbers. And a lot of times multiplying them together is the end all be all. That's the only thing that you can do. So now we remember the rest of our skill beyond finding a common denominator. So once you have found the common denominator, it is best to write the work in the way that I've got it written in. Writing out your fraction work is absolutely the key to accuracy when it comes to this. So in this instance, we have 21 as our common denominator for 2. I'm going back to the first one that we did. So 21 didn't change. So the number that was with 21, which was 9, also didn't change. Anytime you do yes, anytime that the answer to the question of do the denominators fit is yes, there's always going to be one number you don't have to mess with because you're going to use one that was already in the problem. The other number, what we want to think about is how did we get from 7 to 21? What did we multiply 7 by to turn it into a 21? The answer to that would be we multiplied 7 times 3, and that's how we got 21. So you're going to do the same thing to the top number that's with 7. So 3 times 3 is 9 over 21. This will result in 9 plus 9. So you add your tops together, and that's 18 over 21. Anytime you do anything with fractions, you should always determine, is there a reduction or not? In this case, there is a reduction. 18 and 21 can be reduced. This would be one of the scenarios where the numerator doesn't fit into the denominator. So going back to what you ask yourself when you're looking at reduction, does 18 fit into 21 evenly? No. So I'm going to take 18. I'm going to list the factors for 18. I can do 1 times 18. I can do 2 times 9. I can do 3 times 6. And that's basically all my factors for 18. We're always going to get rid of those. 9 would be your next one in line. 9 does not fit into 21, so that's out. Same thing will happen with 6. That does not fit into 21. The one you'll find does fit into both of them is 3. Always write your work out. So come over here and write divided by 3 over 3. 18 divided by 3 is 6, and 21 divided by 3 is 7. So number 2, when you're done and reduced, is 6 over 7. Going back to number 1, where I answered no, they don't fit, and I created a denominator with multiplication. If you create a denominator with multiplication, you're going to have to move both numbers essentially over. So everything changed in the problem. To get from 4 to 28, I had to multiply 7 times. So on this top number, I'm going to do 3 times 7 is 21. And then when I did 7, I had to multiply 7 by 4 to get that to be 28. So then 6 times 4 is 24. Now when I go to add this together, what I get is 45 over 28. You might notice that that is an improper fraction. That is upside down. If you totally remember your process for how to do the division and make a mixed number out of that, go ahead and do that. You can pause to do that. However, that is coming up, so I won't do that right at this moment. That was 2 examples of fractions. Every single pair of these fractions is either going to fit together already or it's not. So if you're looking for a denominator and the smaller one fits evenly into the larger one, you use the larger one. You only have to change one of your fractions, and that makes your common denominator. If the smaller does not fit into the larger, then by default, you multiply them together. You have to change everything to be the new fractions, and then again, you add them together. Subtracting is exactly the same as adding. So for the purposes of this class, the only thing that changes is you do your denominator. You should always write out your steps, especially if you're having trouble remembering what they are. So if you're adding or subtracting, you always find a common first. Then you add or subtract. In this case, I'm on the subtraction page, so I would subtract the top numbers. And then you either reduce the fraction or you convert to a mixed number. One of those two things happens. Those are the three steps. You can sit there and outline your addition and your subtraction sheet ahead of time because every one of them will do the same three things. That is a really good way to not mix up the different types of problems. So if you start out and say, what are my steps going to be? You can see how many steps, what they are. You can draw lines between them. Subtracting and adding are going to have the same steps, except it's going to be a difference between whether you add or subtract. Multiplication has totally different steps. Division has different steps still. And that is a good way to get used to what your work looks like. So I strongly recommend on your addition sheet, write one or two of those in like that. Denominator, add, reduce, or convert. On your subtraction sheet, denominator, subtract, reduce, or convert. The next page is adding fractions when there's more than two, which is something I barely touched on in the other class. I'm going to barely touch on it again. Many of you figure out how to do these no problem because you really took your fraction skills seriously. Others didn't take fractions quite as seriously or didn't practice them quite as much and would be thrown off by this. So I guess my key piece of advice is this is just like the other fraction stuff that you're doing. So you should think about and ask yourself the same kind of questions. Again, there's two ways denominators work on these. They either all have one denominator in common. So essentially one of the three denominators, this time we have three of them that we have to get agreement from, fits the other two. So just like regular addition, no different, one of the three denominators fits the other two denominators equally to where we can use that number and have a common that's common for, in this case, all three of them. An example of that is number 1. 16 is the biggest denominator that we have. We can fit a 4 evenly into 16, and we can fit that 4 as well evenly into 16. So we can use 16. An example where that doesn't work would be like number 3. So either one of the three denominators fits the other two, or that doesn't happen. Whether that be because these two both don't fit, or whether one of them might fit in but not the other. For example, number 4, 5 will fit into 30. So you can almost use 30, but 30 is not divisible by 4. So even though 2 of the 3 of them agree, you would have to come up with your own denominator. And again, just like what I just said with addition, there's either a denominator present that you can use or there isn't, and you have to come up with your own. You're going to do it in the same way. So like number 3 doesn't work because I have 9 and 6. What I can do is I can multiply these together. So 9 times 6. The surest way to get a denominator that accommodates both values is to multiply the values together. That absolutely guarantees that the number you're using is a correct number. That would give me 54. In this particular case, I'm using a smaller value. I just multiplied 2 of them together because the third one is the same. That's not always going to be the case. So like you might have a situation next time where they're all 3 totally different. The 2 smaller ones don't fit into the larger one, and you can multiply all 3 denominators to find out. You could get a really big number. You could be dealing with a denominator like 324. That's okay, because all you did was multiply that, and that guarantees you're using a good denominator. Reduction will fix it later. So in this case, I multiplied 2 of them together. I also could have done 6 times 9 times 6, and that would have made my denominator 324. That's for the same problem, not the one I'm writing it next to. So that's for that one. Either way, that's fine, because reduction will handle the difference in the answers. All we're trying to go for is making sure that whatever denominator we are using is appropriate for all of the other denominators that are present. So now that we're at 54 here, we do the same thing we do with regular addition, except we have to do it 3 times instead of 2. How did I get from a 6 to a 54? 6 times what is 54? The answer to that is I did it times 9. So if I have a 2 and I take that times 9, I have 18 here. 9 got multiplied by 6, so this 4 has to also get multiplied by 6, and that makes 24. And then 6 got multiplied by 9, and again, there's another 2. So I get my numerators based on how I got to my denominators. Now, just like regular addition, I add each of the 3 together at the top. That's going to make 60 over 54. Again, that's going to be a mixed number. You can do that right now, or you can do that later when we come back after mixed numbers. And then this one up here, again, everything works the same way as normal addition, except you're factoring in 3 of them. So it's more complicated at the beginning because there's 3 denominators that have to get along with each other. And then it's more complicated when you're adding them together because there's 3 things that you have to add together. In this case, we used 16, so nothing changed about that fraction. So I can just move all that information over. The thing that changed was 4 got multiplied 4 times. So this 3 up here also needs to get multiplied 4 times, which gives me 12. And then over here, this also got multiplied 4 times, and 1 times 4 is 4. So 12 plus 2 is 14, plus 4 is 16 over 16. Is that right? 12. 18, sorry, 18 over 16. So 18 over 16, again, mixed number. You can change that now if you remember those and you're familiar with them, or you can come back to it. So practice regular adding and subtracting fractions. Then when you feel like you're pretty good at that, you can practice the ones that have an extra with them. The same thing exists for mixed numbers. So the process is the same. The thought is the same. The questions you ask yourself are the same. It just really comes down to whether or not, I guess, the questions are applicable to multiple different fronts. So if you're asking the questions you ask with addition, but you have 3 numbers, you have 1 extra factor in there to say, are all 3 of these compatible? Is there a number that's sitting here that works with the other 2 numbers or not? Same exact thought process. So if you keep them under the same umbrella, you'll be a lot less intimidated by the extra number because you're applying the same exact process. You just have a little bit more that you have to look at. Multiplying fractions, very, very easy. Most of you probably remember how to do it. You just multiply these straight across. The only thing you might find challenge with is when these are mixed numbers because there's a conversion that has to happen. So when we multiply this straight across, 1 times 3 is 3. 7 times 9 is 63. Again, always think about reduction. In this case, the numerator fits into the denominator, so we use the numerator as the reducer, and we get 1 over 21. I won't go into detail on multiplying because I know you guys got that down. Dividing fractions goes back to having steps that you write in. So when you divide fractions, the first thing that you do is you flip over the second fraction. So you rewrite the first fraction, 2/3. You change it to a multiply sign, and you flip over the other one so that it goes from 2/3 to 4/3. Then you actually multiply. So 2 times 4 is 8. 3 times 3 is 9. And that is, in this case, that is your answer because that comes across reduced. So dividing fractions, you flip the second fraction, you multiply straight across, and then you reduce or convert when it is indicated. One thing I did want to point out in this class is what happens when you have 3 that are for division, because division is one that is particularly challenging if they add a third one. It's not actually difficult at all. It's just difficult if you've never thought about what the introduction of a third number would do. So if I have, for example, I'm going to do the bottom one so that I have room to write my work. So 1/6 divided by 2/3 divided by 1/5. When you're doing division and there's 3 of them, you have to do the first 2. And then you have to take the answer that you get when you do the first 2 and then apply the third one. So it's not like addition where you can just get a denominator that's common for all of them and then add it all up at once. When you divide, you flip. So the question that comes up when you get a third one is, wait a second, do I flip one of the fractions? Do I flip 2 of the fractions? Do I flip something now and something else later? And that's the answer, is you flip something now and something else later. Because of the whole flip the second fraction thing, you can only deal with 2 because that really doesn't bring in a third fraction thing. There's not a way to accommodate the third fraction. So we're going to take 1/6. We're going to times 1/6 by 3/2. Write out your work for these. Always write out your work. So you're going to flip. You're going to take your first 2 fractions, flip, multiply. 1 times 3 is 3. 6 times 2 is 12. So I get 3/12. Now I want to take this 3/12 and I want to divide 3/12 by 1/5. So 3/12 divided by 1/5, then we flip. So we have 3/12 times 5 over 1. 3 times 5 is 15. 12 times 1 is 12. So we get 15 over 12. That's how you accommodate the flipping, because you do have to flip 2 different times, and you can only do that when you look at them in pairs, because that's the only way to have the flip the second fraction strategy work. So split them into the first pair, take what you get from the first pair, divide it by the last number, do the same thing, do the flipping strategy again, and that's where you'll end up. There's a couple of other practices that I wrote on there for you to do for those. The next segment that we have is converting with mixed numbers, and then all of the adding, subtracting, multiplying, dividing with mixed numbers. So when we deal with mixed numbers, we have to be really proficient at getting them in and out of mixed numbers. So something we talked about in fraction class is how do you get numbers to be mixed if they're improper, and how do you get numbers to be improper if they are mixed. So the first one that we'll do is the one that's up at the top, which is converting improper fractions to mixed. To do this, we set up a division problem, just like old school long division that you did a really long time ago. And it's really important to use your calculator for accuracy here, but you have to ignore the decimals. So what you want to know is how many times does 8 fit completely evenly into 54? So 8 fits into 54 6 full times. The way I know that is I took my calculator. So you're going to take your calculator, and I said 54 divided by 8 equals. Ignore the decimal. If we wanted a decimal, we wouldn't be messing with mixed numbers. We don't want decimals. But this does tell you that it's 6 point something. So the amount of times that it will fully fit in is 6. That gives us our number for the top. If you remember how old division works, you take 6 times 8, which equals 48, and you now subtract 54 minus 48, and that would give you 6. This is your whole number, just like it was in the calculator. This is your denominator, just like it is over here. And this is your new numerator. Sometimes doing this division is it, and you're done, and that's all you had to do. Sometimes it leaves behind a reduction, as it did in this case. So in this case, we end up with 6 and 6 over 8. The big 6 can be ignored. The 6 over 8 has got to be reduced again. We can reduce it by 2. You use the same process to figure out what number to use. 6 divided by 2 is 3, and 8 divided by 2 is 4. So that's going to end up being 6 and 3/4. This is what I mean when I say there could be reduction absolutely anywhere. There can always be reduction. So even if you're converting a mixed number and you're fully not expecting reduction, even if you're doing something in a proportion problem, you could wind up with reduction. It exists anywhere that it is needed. Same thing we're going to do on number 2 with 39 divided by 5. So again, I take my calculator, I click in 39 divided by 5, and the number that it gives me is 7.8. I'm going to ignore the decimal completely, but 7 is the whole number that I was looking for. 7 times 5 is 35. So I take 39 minus 35, and I get 4. So I have 7 and 4/5. In this case, that is fully reduced already. You have to get used to where your numbers are. That's your whole number. That's your denominator. That's your numerator. The denominator doesn't change, so you know that the 5 will continue to be the bottom number. The numerator is what you find at the end. The whole number is what you find at the beginning. I'll do one more of these. I will do number 3. So 23 divided by 6. 6 fits into 23 3 times. Almost fits a 4th time, but it doesn't. So 23 minus 18 leaves me with 5. And I have 3 and 5/6. So you've got more practice to go on those. This should be a very fast process. I'm not kidding when I say absolutely any of your problems from any strategy could wind up needing this conversion to happen. You could end up with a division that looks like that at the end of a proportions problem. You could end up with it in algebra. You could end up with this anywhere. So as soon as you see an upside down fraction, if the answers aren't decimals, and they almost never are, then you know that you have to do this conversion process and you have to turn it to a mixed. That is not limited to fraction questions. That could happen absolutely anywhere. And then the bottom half is converting mixed to improper. I would say that's the one that most people find easier. So that goes big times bottom plus top over bottom. The thing that these processes both have in common is whatever the denominator is, that's what the denominator is, and that's what the denominator stays. So we're going to use the same bottom number that's right here, and we're going to use it as our bottom number here. And same thing up here, we end up with the same denominator here unless we reduce. If you reduce, you'll no longer see it. So if I do big times bottom plus top for this one, for number 1, 6 times 8 is what I mean by big times bottom. So that's 48 plus 7, and that's 55 over 8. Here I would take 3 times 5 is 15, plus 2 is 17 over 5. Here I would take 5 times 7 is 35, plus 4 is 39 over 7, and so on. Hopefully you remember those processes. Those are crucial to a lot of different things, so hopefully you have a pretty good memory of those. I'm going to talk very briefly about adding mixed numbers, subtracting mixed numbers, and so on. What's really important with this is making sure that you have your steps and your process right. So if you recall, when we did addition, our steps were denominator, and then add, and then reduce or multiply, or reduce or convert. There's an extra step with mixed numbers. Again, you can find all kinds of people who have all kinds of theories about the best way to do this. I base all of the theories that I use, I base all of my favorite way of doing something thought processes on what these tests actually look like and how your skill actually gets tested. I can tell you that they do not give scenarios on the T's or the HESI that lend themselves to leaving something mixed. Don't leave a mixed number mixed while you do the math. In some instances, that would work very well. They know that. The people that write these tests know that there are instances that that would be very easy. They don't put them on there. They make sure the instances they put on there, if you do it that lazier way, that you'll end up paying for it because the answer won't be straightforward. So what we're going to add is convert and then denominator. So we're still adding. So we're going to convert out of mixed number and into improper. Once we do that, we're just going to start up right here as of this line, the normal adding process. Normal adding process is get a common denominator, add the numerators together, and then we would either reduce our answer or we might convert it back. So 5 times 4 is 20, plus 3 is 23 over 4. 8 times 2 is 16, plus 1 is 17 over 2. So we have 23 over 4 plus 17 over 2. Now we can do common denominator using the normal process. There's 2 ways to find a common denominator. Either one of the 2 numbers, the bigger number that's sitting there, fits the smaller one, or it doesn't, and we multiply them together. 4 is our bigger denominator. 2 fits evenly into 4, so we can just use 4. So 4 is going to be our denominator. That means this first fraction is untouched, so it's going to stay 23 over 4. To get from a 2 to a 4, we multiplied by 2. So if you take 17 on the top of that and you multiply it by 2, you get 34. Now we have 34 plus 23, which is 57. Over 4. Now you are at the point where you have reviewed the skill that you would need in order to convert that. So this is not going to be one that we end up reducing. This is going to be one we convert back. We're going to do that using this process right here. So in my calculator, I take 57 divided by 4, and I find out that that will fit 14 whole times. 14 times 4 is 56. So that leaves me with a remainder of 1. So 57 over 4 is the same thing as 14 and 1/4. So you would do the same process on any of these. It's the same as adding fractions, except it might get a little bit uglier numerically because when you convert them out, they are improper, which makes them a little bit uglier. But if you keep yourself doing the steps, label every single one of your questions before you start it as having these steps, you'll be in a very good position to always end up getting these right. So same exact thing with subtracting mixed numbers. So what I would recommend doing as we're sitting here now is just label convert, denominator, subtract numerators, reduce or convert back. If you always think in this framework, it will always be very, very easy for you to remember how to do the problem and to get your steps right. Multiplying and dividing mixed numbers are going to follow normal rules for multiplying and dividing, except again, there's going to be a convert step. Always convert. There is no problem where they give you 2 or 3 mixed numbers and you should just leave them mixed and use them that way. There is no situation like that. So in this case, we're going to have convert and then multiply straight across. And then reduce or convert. So it's no different than normal multiplication. It remains easy like normal multiplication, except you need to convert the number the first time. I'm going to write this in just so you have a guideline numerically. I'm not going to go through this problem slowly. So when we converted these, we got 19 over 5 times 31 over 10. That means that the common denominator is 5 times 10. Oh, I'm sorry. There is no common denominator for this. So 5 times 10 is just your denominator in your answer. So 5 times 10, 19 times 31. So 19 times 31 is 589. 5 times 10 is 50. Needless to say, that is most definitely a mixed number, a really big one. So we're going to take 589 divided by 50. 50 fits into 589 11 times. 11 times 50 is 550. 589 minus 550 is 39. So your answer is 11 and 39 over 50. Same thing with division. Make sure that you add your convert step. So label that now so that when you go to practice those, you've got it down. Convert, flip, don't forget flip, then multiply. So there's one more step than multiplication has, and then reduce or convert. Never try to flip at the same time as you're converting. Never try to flip at the same time as you're multiplying. Always have a flip step where you just flip the second fraction over and change the sign, and that's it. There's a couple more pages on here as a quick heads up of one other possibility of something that you could see. They can put whole numbers into these problems. That will make it look a lot harder initially. It'll look like it's harder to develop the plan that you need to have in place to be able to do this. Keep in mind that any given whole number is that number over 1. So, for example, if they want you to take 9 divided by 1/2, you're going to have 9 over 1 divided by 1/2. When you go to your flip step, you're going to have 9 over 1 times 2 over 1. You're still going to multiply straight across. In this case, your answer is 18 over 1, which means it's a perfect 18. Same thing, I included a worksheet for the same thing with multiplying fractions and whole numbers. The general idea is the same. They could add it to any of the fraction skills that they want to. And ultimately, it would just be a situation where you would either know how to deal with that whole number being there or you wouldn't. And if you don't, that's going to make it really confusing. If you do, you're just going to do the same things you normally do, but you're going to add in a step where you can show this become a fraction first. Then you can multiply or divide or whatever else you're doing. Keep your steps at the front of mind. So when you think of adding fractions, think of the steps that you follow when you add fractions. Same thing when you think of multiplying or when you think of dividing or whatever. So I'm going to break this video here. There's going to be a second half of this video that goes right after this. Just continue straight from here. You have 2 video links, and that will cover from proportions up through geometry. So this video is basically fundamentals and fractions. The second part of the class will clip along a little bit faster, but it's got some of the really important skills. So I'm taking a voice break, and then you'll just immediately play your second video immediately from here. Continue practicing this. This class is a lot more about practice than it is about me teaching it, because either you're really good at math and you just needed to streamline some of your skills, or you already took the math classes and you're reviewing. So the next half will have tons and tons of practice for the stuff that's super important and really prevalent on the test. Definitely complete all the practice from the half that we were just on. I strongly encourage you to use this intense review to really get your strategies streamlined and get yourself to where you always do everything in the exact same manner, and it's always 100% strategic, because that is going to be the best way to make sure that you do well on every single problem they put in front of you. So this packet, I tried to throw in some of those weird instances that only confuse people a third of the time, but then now you've seen it, so now you definitely can't get confused by it. I did my best to put all those curveballs in here that I could think of, but it's really about practice, and you don't want to practice math unless you're practicing your strategy, specifically putting your strategy at the forefront of your thought process. So don't just do your fraction problems, write out your steps, know what they are, be able to visualize them. Then you're filling in the blanks and you're using a consistent process for your problems. That is the key. I always get 100% on math if I take the test. And that's why, is I always think strategically. No matter how good I get at math, I'm pretty good at math now, I still write my steps out. I still convert every mixed number before I try to mess with it. All the things that we just talked about, listing out the factors to decide what to divide something by, I still implement all of those things. I can implement those things very fast. And that's the goal of this giant packet that you have sitting in front of you, is for you to get to that same point where you can implement everything really fast. So that is it for half 1. We will pick up half 2 right from here.